Now we go to logarithmic equation. Okay, that is equations involving logarithm. The other one was equation involving indices, that is exponential equation. But this one is equations involving logarithms. And you must have the prior knowledge of laws of logarithm. That is very, very important. Of course, you know that log 1, this is multiplication law, says that log P base A plus log Q base A is log. You pick one base and you multiply the power. That is log P times Q, or you say log PQ. Take note that it is reversible. You can also, from here, when you have log PQ, can also be split to additive law. Take note. Now, 2. You also have log P base A minus log Q base A. If it is subtraction, you pick one log to base A and you divide the number. That is that. Then we also have another one that says that log, that is the power of the base, the power of the number rather. When the number is carrying another power, okay, you transfer the power of the number to the back, and that is B log P base A. Okay, take note of that. That is when you have, for example, you have log 125 base, let's just say base 5. Log 125 base 5 give you 5 raised power 3. That is 125 is 5 raised power 3. So 3 will come to back as, this is 3 log 5 is 5, and that is 3 times 1. Of course, you know that log of a number to its base is 1, so you have 3 there. So that is just the illustration. So let me talk about that log of a number to its base. Log of a number to the same base. If you have log P and base P, it must give you 1. E.g., log 2 base 2 is 1, log 8 base 8 is 1, and so on. Then there's another law of logarithm that says that log of 1, anytime you have log of 1, you can even press your calculator. Log of 1 to any base is 0. Anytime you press log 1 to any base, it will give you 0. So take note of that. Log 1 to any base is 0. Then there's another law of logarithm that says when the base is carrying power, if it is the base that is carrying power, for instance, we have log P base A raised to power B. You can see now, it is the base. Base is carrying power. But the other one I gave you, that is under the law 3. I say if it is the power, if it is the number that is carrying the power will move to the back. But this time around, it is not the number that is carrying the power, but it is the base A that is carrying power B. What do? You also shift it to the back, but you can see the process it will take when shifting to the back. So the law says that it will be reciprocated. That is, that power of the base will take inverse 1 over B. Then you can now say log P base A. Okay? In what case do we have something like this? For instance, maybe you have log, let's say 16 and 64. Look at it very well. Of course, 16 and 64. Normally, we are supposed to have 64 base 16. But now we are having the reverse. So what you do is just to say this is log 2, or leave it like 16. Then this 64 is 2 raised power 8. You agree? Sorry, 2 raised power 6. 64 is 2 raised power 6. You can see, I just want the base to be reduced. The base should not be more than the number. However, when the number is not more than the base should not be more than the number, just like I said. But however, when the number is not less than the base, no problem. What you just need to do is reduce the base to the lowest minimum so that it will not be up to the number. And that is what I've just done here. So this 2 raised power 6 now is the power of the base. What does it say? It says that we are reciprocating that power. So this is 1 over 6 log what now? 16 base 2. You can see that is now normal. So we can solve this one as 1 over 6 log. Okay, we can say this is 2 raised power 2 raised to the power 4 base 2. Of course, if it is the number that is carrying power, it can come to the back, and that is 4 over 6 log 2 base 2. So what is 4 over 6? 2 here 2, 2 here 3. So we have 2 over 3 times log 2 base 2. That is 1. So this is 2 over 3. Do you understand that? Now we go to the general law. The general law of logarithm. What do I mean by the general law of logarithm? This one can solve any form of question on logarithm. And what is it? That is, when we have log, let's say log p base a, and we don't know how we can actually express it. Just assume that the result here is equal to x. Just say let this equal to x. Now the law says that when you have an equation like that, the base of the log will move, will shift to the other side. The base of the log will shift to the other side and become the base of the number you have at the right hand side. While shifting the base of the log will naturally disappear. So we don't have the log again once you shift the base to the other side. So what you are left with is the number. So p equals to a raised to the power x. Or you can say a raised to the power s is equal to p. Anyone. This is what we call the general law of logarithm. What do I mean by that? For instance, when they say solve log 27 base 3. Log 27 base 3. Let me assume that I don't know how to express it. I will just say let log 27 base 3 equals to x. Just like I said, the base will shift to the other side and become the base of this number. And this number will now serve as its power. So we can say this is 3 raised to the power x. Now equals to what? 27. The log is no more there once you shift its base. Okay? Or we can say this is 3 raised to the power s equals to 27. 3 raised to the power s equals to, we know how to express this one from our exponential equation. This is 3 raised to the power 3. 3 and 3 here we go, and s equals to what? S equals to 3. So that is general, that is general law. The general law of logarithm, okay? Now, last law of logarithm, we call it the change of base. Change of base. What do I mean by change of base? We can decide to change the base of a logarithm if we so wish, or if a condition warrants that. Okay? How? That is when we say we have log, let's say we have log b base or log a base b. And I'm not too satisfied with this base. This base, I'm not too satisfied with it. As in, the base is not that related to this number a. All I will just do is to express it and change it to my own base, the one that will suit the two numbers, both the number and the base. I can decide to change it to log to base c, but you must be careful when you are changing the base. For instance, log to base c, the number will be the one at the numerator over. You have another log to base c, then the denominator here will be. That is what I mean by change of base. You can see we have changed it to a common base, but while changing it, the number is the numerator, while the base now will be at the denominator. You express it as a fraction. For instance, what do I mean by that? When we say log, let's say we have log 64, or let's say log 32 base 8. Now look at this 8 and 30. There's no how I can say 8 raised to the power something to give me 32. So 8 and 32, they are not really going together. So I need a common base that will go for 32 and 8. So I can use log to base 2 as my common base, that is for 32, and also log to base 2 for what? For 8. You can see that now this one will be preferable, so we can say that this is log to base 2 of 2 raised to the power what? 32 is 2 raised to the power 5 over log 8 is 2 raised to the power 3 base 2. 5 can come back, 3 can come to the back, so we can say this is 5 log 2 base 2 over 3 log 2 base 2. Log 2 base 2 is 1, so times 1 here we go, this one will also go. So finally what we have? Our answer is what? 5 over 3, or 1 number 2 over 3.